Norton's theorem. It states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source ISC in parallel with a resistor RO, where ISC is the short circuit current through the terminals and RO is the input or equivalent resistance at the terminals when the independent sources are turned off. ISC is equal to short circuit current flowing across terminals A and B with RL disconnected. RO is equal to resistance measured at terminals A and B prior to the connection of RL, with all voltage sources shortened and all current sources opened. RL is equal to load resistance connected to terminals A and B, and IL is equal to current drawn by the load resistance RL. This is the formula for Norton's theorem. Steps: 1. Find the Norton or equivalent resistance RO across the terminals by turning off all the independent sources, shorting voltage source, and opening current source. Second, find the Norton or short current ISC through the terminals by using any circuit analysis you like. Third, connect RO in the parallel with the load across ISC and apply the formula above to solve for the voltage or voltage of the load. Okay. So now let's try to solve some problem. Find the current through RL. So dito, meron tayong two power sources. And yung sa kon natin ay tatanggalin yung power sources. Yung voltage source ay magiging closed circuit and yung current source ay magiging open circuit, kaya tatanggalin na lang. Meron tayo ditong 3 ohms and then 3 ohms and then 8 ohms. And yung RL natin ay connection natin sa RL ay mawawala na din. So RO, so mapapansin natin na yung 8 ohms at 3 ohms ay in series connection. So mag-add na lang sila. 8 plus 3 ohms and they are in parallel with the 3 ohms resistor. So 11 ohms, they are parallel with 3 ohms. So yung formula natin, 1 all over by 1 all over by 11 plus 1 all over by 3. So yung RO natin ay 2.357 ohms. So i-redraw natin silang lahat ulit, including yung power sources. Three ohms, 7 ampere, 8 ohms, and 100 volts. And maglalagay tayo dito ng VTH. So yung I1 natin ay flowing papunta sa right. And yung I2 ay flowing pataas. And yung I3 ay flowing through right. So let's consider the node C. Let's consider the node C here. So using KCL, I1 plus I2 minus I3 is equal to 0. And yung formula natin, I is equal to V all over by R. So using KCL, 100 minus VC all over by 8 plus yung I2 natin. Yung I2 natin is 7 minus VC minus 0 all over by 6 and it is equal to 0. So papapansin natin, pwede natin siyang i-multiply by 24 para mawala yung denominator. So 24 multiplied by 24. So 24 divided by 8, it will become 3 multiplied by 100 minus BC. Plus 24 multiplied by 7, which is 168, and 24 divided by 6, which is 4 multiplied by BC. So 4 VC, and it is equal to 0. So distribute the 300 minus 3 VC plus 168 minus 4 VC is equal to 0. So let's combine like terms. Yung 300 i-add natin sa 168, magiging 468. Yung 3 VC i-add natin sa 4 BC, and magiging negative BC is equal to 0. So negative yung 7 BC, kaya itra-transpose natin siya sa kabila. 468 is equal to 7 VC. Para matanggal yung 7 doon, i-divide natin siya sa 7. Pati rin dun sa kabila. So VC is equal to 66.857 volts. Yan ang ating voltage potential. So yung VA is equal to VC multiplied by R3. Wait lang pala. Let's consider this as R3 and this as R2. So R3 all over by R2 plus R3. So VA is equal to 66.857 multiplied by 3 all over by 6. And VA natin ay 33.4285 volts. So ISC is equal to VA all over by RO so yung RO natin ay 2.357 ohms. And yung VA natin ay 33.4285 volts. So yung ISC natin ay equal siya sa 14.183 ampere. So to find IL is equal to ISC times RO all over by RO plus RL. So IL is equal to 14.183. IL is equal to 14.183 multiplied by 2.357 all over by 2.357 plus 6, and yung IL natin is equal to 4 ampere. So yung current flowing here ay 4 ampere.